All right, so today we are continuing with our introduction to radians. So I did find some visuals for us. So maybe if you're kind of struggling with what a radian was, I'll put these up in the Google Classroom as well, so you guys can play around with them later. All right. But these are just some interactive things that you can mess around with on GeoGebra. So for this one, it kind of shows you. Actually, let me go to this one first. Here we go. So here we have our coordinate plane. All right, we have a line, and the radius is 2. Okay, so whatever it is, 2 inches, 2 centimeters, whatever, 2 units. So as we drag along and we're rotating, okay, we can see that we have this angle here. So as I move it, we can see that as I move it down, my radians decrease. Right here, I have 1/4 of a radian. As I go up, it increases. So as I increase to 1 radian, okay, that 1 radian, here they showed us on the arc length, that blue arc length is 2 units. Right? So again, if I could take this black line here and I could copy and paste it, and then I can bend it, right? Those two would have the same measurement, right? Or if you had one of those like tailor, when you go get a dress fitted, one of those rulers that they use to measure you, and it's a bendy ruler, right? That would be 2 inches, right? So that is 1 radian. This degree is 1 radian. Right? As we move up, okay, there we have 90 degrees, which I'll be talking about a little bit later. All right, so notice that 90 degrees is about 1.5 radians. And here I have 2 radians now. All right, so this blue measurement is 1 radius length, and now this green measurement is also another one. All right, so then I keep going, and I get 2, 3 radians. Right. So if I could measure this whole arc length, because it's 3 radians and my radius is 2, then the blue, the green, and this pink over here would measure 6, right? Because I have 3 radius lengths, right? That's essentially what radians means, is a radius length on the outside of the circle. Now, again, when I reach this point over here, right, half a circle or 2 segments here would be 180 degrees. 180 degrees is 3.14 radians. We know 3.14 as another number in mathematics, and that is pi, right? So half a circle is always going to be your radius times pi measurement. Right, so here I have 6, and then this would be, 2 times 0.14 would be 0.28. Right, so the green, the blue, the pink, and this little bit, the exact measurement would be about 6.28. Right, but I can keep going, right? I keep going. There's another radian, right? So now I've measured out 4 radians, or 2 plus 2 plus 2 plus 2, okay, 8 units, right? So the blue, the green, the pink, and the gray. Okay, I keep going. Okay, I fit in another radian there. And there we have our last one. Okay, so I can fit 6 whole radians in a circle. And then this last little bit should be, there you go, 6.28. 1 full rotation. 6.28 is another way of saying 2 times pi, right? 2 times 3.14. Right? So that's just another way to kind of visualize what's happening. Right? No, that's not the one I want. Right? Or we can look at it like this. All right. So now what I'm going to do is I'm going to increase my arc length. Right. So again, my arc length is how far I travel around the circumference of the circle. As I increase that arc length, what we're doing now is I'm increasing the radian, the actual linear measurement. Right. So at 1 radian, right, I'm going to move this until I have a 1 there. All right, as close to a 1 as I can get. When I have about 1 radian, right, this green mark, well, then that linear approximation is going to be exactly your radius, right? And then you can keep going around. So here we have pi as our measurement because we went halfway around the circle, okay? This green arc here measures to pi radians, which we saw before when we had half the circle here. Right, and then unfortunately this graph's a little too small, but I can keep going around, and that'll continue, and will it tell me no, we can't make a full rotation, unfortunately. All right, so I'll put these up on the Google Classroom so you can mess around with them yourself, and they actually might come in to help later when we start to convert. All right. So picking up from where we left off yesterday, all right, we talked about degree measurement, all right, and radians. All right, and here we can calculate the radians if we know S, which is our arc length, all right, so from now on, that is going to be a variable that pops up often. Okay, as long as we're talking about circles, your arc length, and that is going to be S. Okay, and of course, R is your radians. Now, theta here, okay, again, we use, where did I put it? Oh, it's on the other page. Okay, we use our theta to talk about our angle. When we're talking about a circle like this, okay, the unit circle, and we have this, we call that, there's a special name for that. Okay, is the central angle because it's at the center of the circle. All right, so again, I'm just going to rewrite this. And 1 full rotation around the circle is 2 pi radians. So again, if your radius was 10 or 5 or whatever it is, if you go all the way around, okay, you can calculate the arc length by multiplying the central angle by the radians, right? Now, moving forward, let's do this. Okay, when we're talking about our angles, okay, on the coordinate plane, it helps sometimes if we can classify them further. All right, so here we have our XY axis. Now on here, okay, we break these up into quadrants, right, when we're talking about plotting it on our standard position angle. Right, so over here, where our terminal angle is, I'm sorry, our initial angle, we start off at 0, right? 0 degrees, 0 radians. as I move counterclockwise, when I reach this positive y-axis, right, that is pi over 2 radians or 90 degrees. Right? And you can tell it's 90 degrees because we have a right angle. Right? That's that. When we make it over here, okay, that's 180 degrees or pi radians. Then we come to the bottom, 3 pi over 2. All right, so what we do is we add, each one of these is a quarter. Right? We break up our rotation, our full circle, into quarters. Right? So 2 pi divided by 4 gets me 1/2 pi or pi over 2. All right, so that's why we break up each one of these segments. Okay, I increase by pi over 2. Pi over 2 plus pi over 2 is just pi. Plus pi over 2 is 3 pi over 2. All right, which is 270 degrees. Now when we make the full rotation, okay, we said that was 360 degrees or 2 pi radians. All right, so when we come full circle, pun intended, all right, we reach that 2 pi or 360 degrees. So we name our quadrants here because they're broken up into 4 equal parts. They are quadrants. Okay, it starts with quadrant 1 in this upper right one, and then we move counterclockwise like our angles do. So over here we have quadrant 2. Down here we have quadrant 3. And finally we have quadrant 4. Okay, quadrant 1 gives me angles between 0 and pi over 2. All right, so all the angles that you will find here will be in between those 2 radians. For quadrant 2, it will be between pi over 2 and pi. Down here, we will be between pi and 3 pi over 2. And then finally, we'll be between 3 pi over 2 and 2 pi. Okay, so moving forward, later on, either later this week or next week, you know, I might reference, oh, we have an angle that is in quadrant 3, right? So you don't know the exact angle, but you know that it's going to be between 180 degrees and 270 degrees, or pi radians and 3 pi over 2 radians. Okay, which brings me to, how do we convert between the two? All right, so we kind of have this original setup to kind of help us, right? We know that 2 pi radians is 1 full rotation, and we know from geometry that 360 degrees is also 1 full rotation. So simplifying this a little further, okay, I can say that pi radians is equal to 180 degrees. Because these two are equivalent, okay, we're going to use this relationship to convert. So if I want to convert degrees to radians, so I start with degrees, right? So what I'm going to do is I'm going to take my angle, and I'm going to multiply it by, well, I want to get rid of the degrees, and I want to make it radians. So what I do is I multiply by a fraction, pi radians over 180 degrees. The reason I can do this is because this is 1, right? pi radians is 180 degrees. If I multiply by 1, I'm not changing anything. Okay, so that's going back to, our algebra and things like finding common denominators. Right? If I multiply something, the numerator and the denominator, by the same thing, essentially, I'm not changing anything. If I want to swap it, what I'm going to do is I'm going to multiply by its reciprocal. I'm going to take my angle and I'm going to multiply it by 180 over pi. Now, what's kind of nice about this is, if you've noticed, our radians has pi in it. Okay, we want to keep the pi there. I don't want to write 3.141518 whatever pi is out. Okay, we use pi for a reason. It simplifies things. So when I'm converting to radians, I'm going to keep that pi there. Oh no, nobody said anything. I wrote the same thing twice. Okay, this is supposed to be radians 2 degrees. All right, and I'll go over some examples to kind of help you out now. All right, so let's take a look at some conversions. First, we'll do degrees to radians. So first I want to take 135 degrees. I want to change that to radians. So let's say, whatever, we're just learning this. We forget which one to use. Should I put pi in the numerator or should I put pi in the denominator? Whatever you want to change to should be in your numerator. Okay, I'm going to change this. You don't have to do this, but I'm just going to write this out. I'm going to write out 135 degrees. Right? It's a whole number, so any whole number I have, I can always put over 1 to make a fraction. So to convert, I want to get rid of this degrees. So to get rid of the degrees, I'm going to put degrees in the denominator so that my units eliminate each other. Okay? I don't know if you did this in Algebra 2 at all, but units work like numbers do. Okay, when you're converting from, something simple, if I want to convert 11 inches to feet, right, I do something similar, right? I put the 11 over 1. Well, I know that 1 foot has 12 inches. So here, my inches units crosses out. And after I multiply, the only unit I'm left with is feet, or feet. Okay, so we can do our basic math cancellation, right, with units as well. And I'm going to put the pi up there. All right, pi radians. So now what we do is the pi just kind of tags along for the ride. So I have the fraction now. (135 over 180). Now, I don't know if you noticed when I was setting up the coordinates, right? We like to keep our radians as fractions, all right? I don't want to have 0.5 pi radians, okay? I'd rather have 1/2 pi radians. It looks neater. It looks cleaner. So all you're going to do in this situation is reduce this fraction. Okay, 135 over 180. So you might have to do it the long way, right? Divide everything by 5, find common multiples and divide. But you can also change it to a fraction. So 135 over 180 reduces to 3/4. So I can say that 135 degrees is 3/4 pi radians. Or another way we can write it is usually the pi gets thrown into the denominator. So we say 3 pi over 4. Okay, so when you're going from degrees to radians, you're not doing much other than just simplifying a fraction. You're going to take your degrees, put it over 180, simplify that, and tag on pi on at the end. Going the other way, say we have radians first. Okay, so now I have pi over 6 radians. Now, in this conversion, I don't want the pi there anymore. Having pi with degrees, that's real ugly. All right, we don't want that. It's not mathematically nice. Right? So again, if you get stuck, you don't know which one to put. Well, if I want to get rid of a pi that's in the numerator, I have to put that pi in the denominator. So not only does my units eliminate each other, the pi's eliminate each other. And then usually what you're left off with is whatever fraction you have here without the pi, so this is 1/6, times 180 degrees. Right? Or 180 divided by 6. Then we get 30 degrees. Okay, let me do one more real quick like that. And so if we have 5 pi over 3, okay, again, I'm going to multiply that by 180 over pi. So automatically my pi's eliminate each other. So now all I'm worried about is 5/3 times 180. Right? So say you don't have a calculator with you, whatever, your phone's offline or something. So a quick way to do this, I like to divide by the denominator. 180 divided by 3 is 60. And then multiply by the numerator. 60 times 5 would be 300. Right? Or, again, if you have the calculator, you can just type in 5/3 times 180, and you get 300. All right, any questions about our conversion?